Hello and welcome. Thank you for joining us for the APsmart Rapid Shutdown webinar. I'm Jason Higginson, the Senior Director of Marketing in the US for AP Systems. I'd like to start by introducing today's panelists. On the call with me today, we have Olivier Jacques. He's the President of Global Business Units and Global Executive Vice President at AP Systems. Olivier brings more than 20 years of experience in industrial, energy, and high-tech industries to his leadership role at AP Systems. Joining us, we also have Tom Tansey. He's the chairman of the SunSpec Alliance, where he leads the distributed energy industry's efforts to establish data and communication standards that enable seamless integration of solar PV and storage into the smart grid. Tom was also the work group leader for the development of the SunSpec Rapid Shutdown specification. We also have Chris Barrett, Senior Director of Technical Support for AP Systems USA. Chris has been with AP Systems for close to 5 years, and before that he was with SolarBridge Technologies, and he has extensive experience in semiconductor and power technology. We're all excited to be with you here today. A brief agenda. Olivier will be leading us off with an introduction to AP Systems for those of you who are not familiar, and also introduce our APsmart brand of DC MLPE products and how that fits into our overall offering and strategy. Tom Tansey has graciously agreed to join us to talk about SunSpec, what they do in their Rapid Shutdown initiative to develop an open standard to meet the market mandate for solar safety. And then Chris Barrett will introduce the APsmart Rapid Shutdown solution and walk everyone through the details of the product, operation, installation, and available options of the RSD offering. Olivier, I turn it over to you.
AP System is a global provider of MLPE, and by global provider of MLPE means covering all the needs and requests that customer may have when looking for MLPE solution on PV. Serving all the planets through business unit and offices in the US, EMEA, Australia, China, Latin America, including through all the business unit and offices, dedicated team to work very close to the customers and serving on a global viewpoint our MLPE offer. We have manufacturing capability in China and Taiwan, taking care about both the AC series that we will see a little bit later and the DC series that includes the APsmart and the Rapid Shutdown. We have 2 R&D centers, one in Jiaqing, that is the main one, and an antenna of R&D based in Cupertino to the Silicon Valley in the US. And we are serving today more than 80 countries through our business unit and offices through the globe. When talking about MLPE product line, it's interesting to see that since the foundation of the company in 2019, the company has grown, developing, manufacturing, and marketing a consistent range of MLPE product through the core business, the microinverter, starting from the single style up to the quad, and being today for far the widest provider in terms of range of AC series microinverter, and very consistent and advanced monitoring. The company turned profitable very soon after its foundation in 2012, which is not common on the PV industry. And something very interesting is the company seriously maintained its profitability since that date, year over years, and still very consistently profitable. 97 patents. This is starting another part of the presentation of the company when we talk about innovation. Innovation is the DNA of the company, and we today have 97 patents protected, but more than 140 if we include all the patents in progress. The multi-platform MLPE can be translated in 4 main divisions inside the company. In one side, we have AP System. AP System covering and taking care about the microinverter series, which we call the AC series, all AC. and that provide and develop a consistent microinverter range, going from single, duo, quad, and even going through a three-phase microinverter that is a unique innovation from APsystem. In the other side, we go from the software, covering all the need for internal software. That means the software that we are using in our own product, the EMA software for monitoring, and the SaaS, that is another department of the company, providing the know-how of the company on software to help company to qualify and get a more consistent and fine-tuned monitoring. Then we go to the residential ESS for AP storage, where we dedicate these departments to develop a range of residential battery that's not been launched yet, but are in progress. And at last, the DC series, developing the rapid shutdown and smart module, which is the subject of today, and developing a very well-designed and advanced rapid shutdown solution. The product value chain and the digital PV ecosystem of the group that you can see on that slide is giving a little bit more detail about what I just described on APsystem, the fourth division. So the key and core business that we have in the center is covering from the AC series microinverter and the logical development coming with the DC series, that is a rapid shutdown solution. On the two other side, interesting to see that to make it working on the right way, we need monitoring and we need some electronic and energy management that is covered with the energy management department. And we also own part of the chips that include in our manufacturing through IC chips, which is a company manufacturing and designing the chips for the PV and for our own product. So the company key fact is, as I said just before, the first thing is innovative. The DNA of the company since the beginning is innovation, trying and striving to develop and release very innovative product. So we today are the worldwide widest MLPE range and delivering unique product in the solar marketplace. And this is true from the microinverter, from the monitoring, that it's a very advanced monitoring and energy management solution, up to the DC series with the rapid shutdown that has recently been launched with a very innovative and unique design. Bankable, company bankable since 2012. This is extremely important. We are providing product with warranty going up to 25 years. And to qualify our 25 years warranty, we need to make sure that the company is here today and will be here tomorrow on a safe place. Reliable. Most of our product and all product are designed for over 25 years life. Proven, we today have more than 100,000 installations worldwide. Global, we are able today to offer and provide our solution in all the range of products in all the globe and covering all the region with dedicated team. And when we say dedicated team, it's covering the sales, covering the marketing, and covering the technical support. Going quickly on the company brief history that we already have some tests about it. In 2010, company has been founded in the Silicon Valley, by the way, in the US, before to relocate in 2011 the headquarters in China, close to Shanghai. In 2012, Seattle office has been opened to serve the American markets, and first flagship product with the Duo YC500 that has been a success story has been launched through the US, and then gradually in the other country. In 2013, the company launched the first worldwide three-phase microinverter, which is still today a very strong innovation when we talk about microinverter going on a real three-phase, not a three-phase through a cabling design, but a real three-phase native product. In 2014, the company started to expand in Europe and open a warehouse and offices in Rotterdam, in Netherlands, and the same years opened the Australian operation. In 2015, a company get over 215 megawatt, which was a kind of new step for the company. And again, companies start to involve a little bit more in EMEA with another office in Lyon to serve the other parts of Europe. 2017, the Latin America has been addressed, and AP system get over 400 megawatt installed. And the last 2 years, we launched a new generation of products with power factor controlled, quad on a single phase, and of course in 2019 has been the launch after development of the rapid shutdown product. The company has committed shareholder. That's also extremely important. We are not driven by the emergency to feed investor at any price and doing many compromise on quality or on innovation. We don't do that. The company has committed shareholder. What does it mean? It means that we profitable and our shareholder support the company development through the innovation process and not in a hurry to get back all the money that they found. That's very important and allow the company to maintain its innovation and MLPE leading position in the market. We have a financial approach that detects the way we want to grow. That means that the way we want to grow profitably and organically. And we strongly supported by our biggest shareholder to continue on that way. The US sales network. So very briefly, we are targeting on the first step, as you can see in orange, the 3 direct customer profile. OEM solar inverter manufacturer, that inverter partner that integrates our product in their own offering and offer to the distributor, or for some of them, depending on the network they got, directly to the installer, they inverter equipped with our rapid shutdown solution, receiver and transmitter. We also look to the large T1 project companies, large EPC company that may also buy through the OEM solar inverter or through the distributor. And from the other side, we also go directly to the distributor that are involved on commercial project and able to store and deploy our offer through installers. Couple of partnership examples showing how we penetrate that market on a rapid shutdown. So we have consistent partners through module partner like Trina, Jinko, Canadian Solar. We get very close relationship and partnership with inverter company like Delta, Frenius, Solis, CPS, Yaskawa, Growatt. And we start to expand also to the distributor that are looking some commercial project like Power Store and many more coming very soon. We have many discussions, very well engaged to deploy our offer through very serious partner. A summary about our competitive advantage. We can say many things about the competitive advantage of APsmart. Let's focus on the four competitive advantages that make a sense when marketing and selling a rapid shutdown solution. It's powerful, and you will get much more detail through Chris about what means powerful when we talk about rapid shutdown. Very smart design, not only a very compact product, but also a super easy and plug and play product. Reliable, as I just mentioned, all the policy of the company is to make sure that we design and we release products able to work up to 25 years, taking into account that we offer a warranty of 25 years on that product. And cost effective. Cost effective on rapid shutdown is a key point. It doesn't mean that a cheap product, it means a cost effective product through the market. So who is APsmart? So technology developed by experience from AP System team. APsmart is a department belong AP System, and it's a logical extension of the know-how of AP System doing microinverter, a manufacturer of microinverter. Going to rapid shutdown is a guarantee for the customer to get rapid shutdown that is going to provide what it promised to do. The microinverter includes a rapid shutdown by essence, and AP System is manufacturing and designing microinverters in 2009. So the rapid shutdown is not a new thing for AP System. That's a large experience on the rapid shutdown. The experience of AP System team has been to remove this technology from the microinverter and make a smart, compact, and cost-effective solution focused on the rapid shutdown and SunSpec qualified. It's ideal for, It's ideal for any new or existing string or central inverter. By design, the product has been made to fit new installation or existing and retrofit installation. It meets all the NEC 2000 saving 619 rapid shutdown requirements. And everything on the rapid shutdown, that it's a small and a very cost-effective product. On this very small product, it gathers all the know-how and expertise of AP System in MLPE, providing the guarantee that going through the rapid shutdown in APsmart is like to buy all the expertise and the know-how of AP System Group. Thank you.
Thank you, Olivier, for that introduction. Our next speaker is Tom Tansey, who is going to briefly talk about SunSpec and their rapid shutdown initiative. Take it away, Tom.
Great, thank you. Good morning and good day to all of our viewers tuning in from around the world. My name is Tom Tansey. I'm the chairman of the SunSpec Alliance. We got started about the same time that AP Systems did, 2009. We have a mission to develop information standards for the DER industry. By background, our people come out of the software and networking business. And as we have gone into the renewable energy world, what I saw at that time is the absolute opportunity to transform the market and make a bigger pie for the whole industry by adding intelligence and data communication to these solutions. In the early days, the message that we were putting forth was a difficult one in some ways, because the industry was just finding its way in terms of establishing solar as a category. As time went on, though, things have become quite a bit easier. Certainly as these various suppliers have come together and met in systems, the need to do system integration became immense. And so as a result, SunSpec came into being, and one of the first things that we went about standardizing was the interface to the solar inverter. So that was one of the very first standards that we published in 2009. You fast forward about 10 and a half years later, we have over 110 members that are represented from all parts of the globe. We have a network that reaches into over 1,000 different adopter and partner organizations, those that use and buy and deploy SunSpec-based solutions. People are often confused about what and how SunSpec operates. It's actually pretty simple. We're a trade alliance. We get together with our member companies and do advanced research and development in fields that it wouldn't be cost effective for any one of them to do on its own. But when we come together, we're able to create a standard for common good, and that then allows the market to grow. We work both in the international standards arena, and which I'll get to in greater detail in just a moment, but also in the de facto standards development. And a good example of a de facto standard that I'm referring to is SunSpec Modbus. And so by de facto, those are the types of standards that become a standard by use. And so starting in 2009, we pioneered this concept of a common interface to these devices that make up the PV systems and the distributed energy systems. And it turns out that as time went on and the need for diversified supply chains became more apparent, that became a very popular standard. And that then leads to the international standards aspect. So we have always from day one been looking to work our way out of a job, if you will, because these standards do want to be international and official in nature. And in 2018, SunSpec Modbus became part of the IEEE 1547 standard. And it is now part of that standard today. And as you may have heard, the 1547 standard was approved just last week, making it the law of the land. So we work in many other fields as well. And the one that we're talking about here is the communication that takes place between the PV module and the solar inverter for the purpose of safety. That's the SunSpec Rapid Shutdown standard. But in addition to that, we're also working in application-to-application communications through the Orange Button. That was an initiative funded by the U.S. Department of Energy. And we're having a great time working with our member companies to make this a bigger, more profitable market. You can see our board representatives there. It represents a pretty diverse cross-section of technology partners, everyone from ARM, who is a company that maybe you haven't heard of, but whose products you likely use if you use a mobile cell phone, on down to system providers, power conversion device manufacturers, system integrators, and of course, the safety testing organizations. Next, please. Right, so we believe that a great way to drive adoption is through standardization and grid codes. Now, this is an approach that takes patience, but if you stay at it long enough, it actually matches up pretty well with this idea of data communication standards, which are standards that take a time to mature. So where we've seen success in driving through to international standards, first of all, I mentioned SunSpec Modbus. It's now the U.S. national standard through IEEE 1547. In 2019, the country of Poland also adopted SunSpec Modbus for its DER standard. And earlier than that, in 2015, the very first country to jump on with SunSpec was Denmark, which has made it part of its national grid codes. Now, the SunSpec Modbus is a protocol that deals with communication within a PV or DER system itself. So when you go beyond that, from the system to now communicating with the grid operator, you're looking at some different protocols. And so in the US, one of the popular protocols there is IEEE 2030.5. SunSpec had a hand in forming this standard as well. In 2012, we contributed the SunSpec information models for distributed energy resources to the IEEE 2030.5 standard, which at that time was under management of the Zigbee Alliance. We since then kept our hand in it to further develop that. And today, IEEE 2030.5, like SunSpec Modbus, is part of the IEEE 1547 standard. I'm sorry for throwing all these numbers at you, but if you're in the business in the US, you'll know that IEEE 1547 governs all of DER, and it now requires that DER communicate. And so IEEE 2030.5 is another way that you can do that. SunSpec additionally has responsibility in the state of California for running the test and certification program for the state for the rollout of California Rule 21. Orange Button, I mentioned, is funded by the US Department of Energy. It's a little different from the standpoint that it's used for data exchange between systems involved in distributed energy resources. Its purpose is to facilitate operations and financing of solar and distributed energy assets, and has also been enjoying quite a lot of success. So we had over 500 companies involved in the formation of this standard, and we're now into the second or third level of development there and are gaining new members and new customers all the time from it. Finally, the point of today's conversation, SunSpec Rapid Shutdown. This is another example of a de facto standard. So in 2015, a group of 30 SunSpec members asked us to take on and lead this initiative, looking out in the future that the NEC 2017 would soon be ratified, requiring module level rapid shutdown and ultimately a communication method to control and to manage that solution. So since 2015, we went to work. We published the standard later in 2017. We went through a period of deployment and dissemination throughout industry. And then finally, starting in 2019, started to see products come on board and adopt the standard, AP systems being one. And at this point, the ecosystem is growing very nicely based upon the premise of the SunSpec Alliance, which that interoperable data communication standards supported by a wide variety of vendors can in fact expand the distributed energy market, make solutions easier for customers to understand and to absorb into their supply chain, and to keep their operations running smoothly and profitably. Next, please. In terms of certified products, SunSpec started, as I mentioned, in 2009, certifying for the SunSpec Modbus. And there you can see that we have the most mature lineup of certified products, 52 product lines from 36 different vendors. From there, we have expanded and now include the IEEE 2030.5 CSIP product line, 19 product lines from a total of 15 vendors. This is initially in support of the California Rule 21 rollout. And then finally, in our most recent product line to go through full certification, SunSpec Rapid Shutdown, where we now have 6 vendors that have certified products, and we just broke double digits with a total of 10 product lines that are able to utilize this plug-and-play multi-vendor solution. Now, so why certification and why multi-vendor interoperability? There are 3 primary reasons why this is a good idea. The first one is consumer choice. As a consumer or as a system integrator, you don't really want to be able to or have to rely on your choice based upon some obscure technical requirement. You want to buy and use products because you like them. They offer a better customer experience. They're easier to integrate, whatever your reason may be. You want to have that ability to choose, and multi-vendor standards allow that to happen. Secondly, lower system support expense. In an arena where you have proprietary solutions, you also have a proprietary and segmented knowledge amongst the workforce. This means that the customer experience becomes dependent upon individual people rather than the overall company. With the multi-vendor solution, where you have common methods for integrating, managing, and supporting, that just simply results in lower overall system support and expense. You take that all together, you end up with higher overall stakeholder satisfaction. You have more choice for the customer, lower system integration costs, and ability to innovate based upon factors other than mere compliance are all the elements that feed into that equation to make stakeholder satisfaction higher with multi-vendor solutions. So why rapid shutdown? Why is this an important initiative for SunSpec and for the industry? In 2015, it became clear that the solar industry was going to be very large and that rooftop solar on residences, commercial buildings, and the like would be a very popular area to deploy this type of technology. And so looking at the state of the art, it became clear that there are some things that we could do better in terms of making the solution even safer for our consumers. And so that's how the Rapid Shutdown Initiative was born inside of the National Electrical Code for 2017, and how the SunSpec communication signal for rapid shutdown standard was also born. As of 2020, 34 states require it, more coming online. Importantly, the SunSpec solution is open and royalty-free. So as I mentioned, the 30 vendors got together. That ecosystem is expanded well beyond that number and range. None of them pay a thing for the use of the SunSpec Rapid Shutdown standard. And as a result of this publishing environment, anyone who has an interest in examining how the technology works and wants to understand it has the ability to do so. You can download the specifications from our website. Those two elements are not sufficient. You need rigorous compliance, rigorous test protocols, which we also developed and have implemented and utilized a total of 8 SunSpec authorized testing laboratories to test products for compliance to the SunSpec Rapid Shutdown signaling system, and then ultimately to provide the certification mark, which is the buyer signal of confidence that the products that they are finding that are rapid shutdown compliant will actually work together well in the field. All right, so how do you find these types of products? So if you look at the upper left-hand corner of the screen, you can see the URL certifications.sunspec.org. That's the home of the SunSpec Product Certification Registry. This contains all the SunSpec certified products of all the different types that I mentioned previously. You have the ability to search and sort by vendor type, vendor name, or by product type. And this is an interesting and convenient solution, I think, for purchasers of this product. And for those that are on the manufacturing side, you know, one of the challenges is getting your product whitelisted with a jurisdiction that has responsibility. For example, California has this so-called CEC list. Well, this solution is effectively an improvement on the CEC list. And in fact, we offer it to authorities having jurisdiction, give API access to them so that any one of them can utilize the system to get the particular details on these products. So if you go to the site, you'll be able to see exactly what product models were tested. You can find that through the PICS, Product Information Conformance Statement, and ultimately what product models were certified. So all that's available to you, offering a complete transparency with regard to this solution. And in closing, I welcome you to learn more about what's happening with the SunSpec Rapid Shutdown ecosystem, because it's growing and expanding. If you visit rapidshutdown.sunspec.org, you'll see all of the latest information that we're publishing, the various places that you'll see our name in print. We're doing all sorts of information, webinars like these to get both the message out and help people understand the value of these multi-vendor solutions, which in fact I think are the backbone and the foundation of this industry going forward. If you'd like to learn more, you can also just email me. You see my email there on the screen, and I'm happy to take any of your questions. Thank you.
Thanks, Tom, for that background on SunSpec and rapid shutdown and the importance of the solar safety and multi-vendor interoperability. It's a great tee up for what Chris is going to cover on the APsmart RSD solution that does just that. Take it away, Chris.
Yes, thank you very much, everyone. Thanks for coming to the thing today. And Tom, thanks very much again, like Tristan said, teeing this up for me as well. Today, I actually want to introduce the Rapid Shutdown solution. This is the product that was designed to solve an industry problem that we've had since 2014. Rapid Shutdown goes back to 2014, NEC 2014, 690.12, requiring rapid shutdown on all roofs. 2017 then added the extra bit of element of rapid shutdown module level. With this RSD device, we were actually able to shut down those modules, module by module, to be within the under 80 volt touch safe voltage required by NEC. Within 30 seconds and 1 foot inside the perimeter of the array. The RSD itself is a very simple design. Again, like I said, it meets the NEC 2017 690.12 requirements for module level shutdown, because this particular device is actually installed on every single module in your installation. Meets all the SunSpec Alliance requirements, just like Thomas mentioned here. As far as the flexibility, it's small and lightweight. It can be mounted many different ways. It can be mounted via adhesive to the back sheet of a device, of a module. It could be mounted via the module, via the clip system, or even racking mounting. One thing we're finding, this is actually a very good solution for bifacial modules as well. Regards to reliability, you couldn't get much better. This is a proprietary design by AP Systems with a system on a chip design with redundant topology. So we're basically trying to reduce components to increase reliability of this particular product. As far as the construction and features of the product, low power consumption. So it's very powerful, but as far as the power consumption is very, very low. The minimum operating voltage, 7.7 volts, which means we're going to come on earlier in the morning and stay on later into the evening. So you look at that, it's 15 to 30 minutes in the morning and maybe 15 to 30 minutes towards the evening. But you add that up over a period of time, that's a significant amount of power production that is gained by using this product. As far as stability is concerned, eliminates any of the arc fault issues that many of the string or central inverter people face. If you look at the graphs over here, the graph over to the left here is the RSD-PLC noise. This is the actual device itself. This is what we're looking at. It's well below the reference line here. The second over here, the standard AFC noise, this is what you typically would see in a string inverter situation. So like I said, the APsmart solution is well below this reference line right here, making this for a clean, easy installation without any chance of any kind of AFC nuisance breaking. As far as the data and dimensions are concerned, here it is right here. Very simple. Input voltage, 8 to 80 volts. Maximum input current, 15 amps. Maximum solar panel size currently is 550 watts input. Output, of course, 0 to 550. And string voltages for 1,000 volt systems or 1,500 volt systems. Temperatures, minus 40 to 85. This is ambient operating temperature. And it meets all the safety compliance for NEC and EMC, FCC, and also CSA. So let's dig in a little bit. So we're right here, this is basically a system overview of a SunSpec RSD compliant inverter, which means that the transmitter that we see right here is actually installed inside of the inverter itself. This inverter right here has this PCBA board with the cores installed, monitoring the RSDs that are on every single panel in your solar system. The transmitter itself is very simple design, as you see right here. So we have a voltage input for the power to the device, an LED so you can actually see status of the device, a place to install 2 separate cores, as you see right here, the CT cores, and then a signal LED. This particular device, again, meets the requirements for NEC 690.12 because we're looking at the module level. The device itself will switch on and off basically via the AC detection. Dual core, again, it's 150 amps per core. And then we also are actually able to supply either different power supplies depending on if it's a residential or commercial environment. So 2 different power supplies, and we'll go more into detail as we get deeper into the presentation. As far as the technical data for this device, input voltage, again, 12 to 24 volts. Very low, easy to do. Input current, 0.5 amp. The communication is PLC or power line communication, times 2. So 2 cores, single core 150, 2 cores 300. Input voltage, again, the maximum is 1500 volts. The number of strings per core is 10 per the SunSpec Alliance code. Number of modules, most important here is 30 modules per string is the maximum per the SunSpec Alliance. And again, meeting all the safety and EMC compliance. Okay, so for example, let's say you have an inverter and you need to install rapid shutdown compliance, but the inverter that you have does not have the SunSpec compliant inverter. You can actually add that piece right here by installing a transmitter in an outdoor kit. So basically, you're going to be able to supply this particular box, supply the power supply from us, the transmitter from APsmart, and also the RSD device. This is where you're going to take a dumb inverter, a standard inverter without the rapid shutdown included, and actually include that rapid shutdown to comply with the NEC 2017 690.12. And here it is right here, just a better example. So on the left-hand side here, you'll see the power supply. This is the power supply that's going to be fed with the AC, DC out to the device, to the transmitter. Down below, you see the 2 cores for measurements. Again, meets the NEC requirements. Transmitter is rapid shutdown compliant, meets all the SunSpec requirements. And again, 2 different voltages depending on which, if you're in commercial or residential. It's a nice tool right here. This is a tool that AP Systems sells, and this is called the RSD-I detector. This particular device is a tool. It can actually have 2 different modes here. The tool itself, the tool itself actually goes into a detection mode. This is a device where you are actually able to take this device, turn it on, and put it up against a DC lead to verify or hear or feel the heartbeat coming from the transmitter. The transmit mode is actually being able to generate a heartbeat. Let's say, for example, you're doing installation, you're doing troubleshooting. This is actually give you the ability to be able to actually simulate that heartbeat in this mode here. Okay, let's get into the installation. Regarding installation, there's a few different ways to install this product. First method is actually to take and slide the RSD device into the module frame. And this right here is on the inside of the module frame. You can see right here the clips. The clips that I'm showing here actually are mounted on the RSD device and actually ship with it. Method 2 is to actually insert this device on the front side or the face. Just sliding in. These right here, these metal clips will engage with the aluminum on the rail itself, on the frame itself, engage and lock in place. And it's really, the location-wise, is there's more of a convenient location for you. Probably somewhere close to or adjacent to the J-box. So step 2 is now you're making all your connections. You're going to go through the effort and you're going to create the lines. You're going to connect all the RSD devices together, and you're going to connect all the RSDs to the module J-box. Keep in mind, again, the maximum number in a string is 30 modules. As far as the methods are concerned, this is actually a good shot right here. You can actually get a good feel for the RSD device being on the face or the outside of the front of the module. Let's say that we call it the back buckle. This is actually underneath the module. What we're trying to show here is a little bit of wire management as well. This is for the split cell modules here on the left. And we do the same thing over here for the traditional J-box. Again, we're doing a front buckle or front mount, a rear mount, if that's the best thing for your application. And in some particular cases, we've seen this before with a split cell modules that have very short DC leads. We're actually able to take a 3M tape and actually tape this device right to the back sheet. So the transmitter itself is comprised of 3 different pieces, basically. You're looking at a power supply to supply power from the AC coming in to the device, DC out to the transmitter, and then the 2 cores that are doing all the measurement. In this particular example, we're showing that you can actually purchase these components and install them yourself. So let's say you want to go out and buy your own enclosure. That's fine. If you want to go out and buy your own power supply, that is also fine. The AP Systems transmitter here, buy it, core, assemble it yourself. We also offer one-stop shop where you can actually buy the enclosure, which is a NEMA 4 or better box, the power supply supplied by AP Systems, the transmitter, and also the cores. So we give you the flexibility to do with what you would like, how you like it. System wiring, here it is. It couldn't get much more simple. Again, starting from the inverter here, working your way in, you're seeing the DC leads. It doesn't matter if you connect onto the DC positive or DC negative. It doesn't matter. It's what we want to do is be consistent. So it's either the positives or negatives. That's all I care about on the cores. The transmitter is transmitting over the power lines out to the devices, creating the PLC connection, the keep alive message to keep everything up and running. And one thing I want to just point out though, the maximum cable length is 1,000 meters. So I know some of you have ground mounts, longer distances to the inverter from the ground mount. Just be careful because like I said, the PLC communication strength is up to 1,000 meters. Okay, so let's dig into a little bit more of the application of the RSD. Okay, so when the RSD is sitting there and actually installed on, the RSD itself is sitting on the modules plugged in. The transmitter is over here trying to communicate, but at this point you see the circuit breaker is turned off. There's absolutely 0 AC to the system, which indicates to the RSD that it's in an off state. In an off state, the RSD device will produce, when it's connected to a module, 0.7 volts, as you see up here. 0.7 volts per RSD. So when you're actually in an off state and this thing is just sitting there idle, what you can do is you can take 0.7, so the voltage of that string times 0.7 equals the number of RSD devices that you have installed on that string. This is just a good verification for you to be able to verify that you've installed X number of RSDs times 0.7. Check with your multimeter, you'll be able to verify that everything's installed and connected properly. As soon as the system is installed and powered up, as soon as the system is turned on, you see here the circuit breaker is now on. We're getting information from the grid to the inverter. The transmitter is now transmitting the keep alive signal. The RSD device will then turn on and allow the full open circuit voltage from the module to energize the circuit. And again, that's all happening because of the transmitter. The transmitter is sending a signal to the RSD, which is in a normally open state. So we're closing that state so we can get the full potential of every single module. Again, now to verify what we've just done, the voltage on that string is the VOC of the module times the number of RSDs. Just like before, when it's in the off state, when there was no AC to the site, it's 0.7 volts times the number of RSDs. When the grid is on and active, now you're looking at the nameplate rating of that module, the voltage rating, the VOC, times the number of RSDs. Okay, so let's say, for example, in a system shutdown situation, again, power goes out, the breakers turn off, rapid shutdown is engaged. At this point, the rapid shutdown, the RSD device will shut down in 1/10 of a second. What they're monitoring, the signal now is lost. The RSD goes back into its native state, which is off. And then the rest of the DC lines are actually able to then deplete their voltages and get to less than 30 volts in 30 seconds per NEC 690.12. Regarding the restart, is as simple as this, as simple as turning back on the breakers and re-engaging with the grid. As soon as the system senses the grid, the RSD transmitter will send a message down the pipe over to the RSD system, and then within 10 seconds, that right there will actually turn on and we'll see the full potential of that module. Mind you, that the inverter won't start producing until 5 minutes later. The reason is IEEE 1547, which states that when the power is lost, power must be regained, proper voltage and proper frequency must be met, and after that dwell period of 300 seconds, then the inverter is able to turn back on and start producing power. As far as certification and test results, we actually have lots of NRTL certifications, both through CSA certification, TUV, FCC, and SunSpec, of course, all of which is located on our website in our library section. If you'd like to see them or download a copy of them, all available. Specifically, CSA certifications for 1741 E2, again, located on our website. For you, feel free to look at that or peruse that information as needed. And I want to share with you just a list of compatible inverters that are currently on the market today that actually have the SunSpec Alliance certification built into them, the transmitter. So this right here, all of these particular inverter manufacturers can work and play nicely with the APsmart solution for RSD.
Awesome. Thank you, Chris. At this time, I'd like to open it up for Q&A. So if you have a question, please use the Q&A feature on your Zoom control bar to ask us a question. And it looks like we have a couple queued up here. So let's get started. All right, our first question, Chris, is does the APsmart RSD solution need a switch to turn on?
Actually not, so no need at all. So there's no switching involved. It actually happens all automatically. So the transmitter, that when it's powered via AC, that sends a DC to the transmitter sends a heartbeat down the line to the RSD device, which automatically turns on when that AC is present. And then, and conversely, when the AC is not present, it will turn itself off. Good question. I got a question coming in right here. It says, how to monitor APsmart RSD systems? Well, it's an interesting question. I think we covered that a little bit, but let's just talk about it again. There are basically two ways to monitor the APsmart RSD system. The one was that tool we talked about, the RSD-I. That right there is going to be able to give you the ability to test or check for that heartbeat. That heartbeat right there is going to tell you that the transmitter is working, it's pulsing, it's giving those RSD devices the information it needs to turn on and operate properly. Second would be the multimeter, by measuring basically the open circuit voltage on the devices. So like I said, in an off state, when that circuit is open on the RSD, each RSD will feed, each module will feed the RSD device. It will actually receive 0.7 volts on that device. So you'll actually be able to see that voltage with your multimeter. And like I said, if you have, let's say, for example, 30 modules on a line, times 0.7 equals 21 volts. So at 21 volt, you would read 21 volts on your multimeter in the off state. In the on state, of course, it would be dependent on the module itself. So it really depends on the VOC of that module times the number of modules that you have on that system.
Great. There's another one that says, how do I contact APsmart technical support, and is it local?
Yes, absolutely. So we give you multiple means through which to contact us. So the first answer is yes. We have local support here in the United States. We can actually include the phone number. I'll tell it right now, but we'll include it in the presentation as well. Phone number is 737-218-8486, or you can email us at apsmart.support@apsystems.com. And we also actually offer a web version as well. So if you go to our website, apsmartglobal.com/support, you can enter a ticket there as well, and that will get to our technicians. I see another question coming in here. Does APsmart RSD provide module level monitoring? Actually, it does not. All the power production is recorded at by the string or central inverter as an aggregate.
I see a question that was asked and answered in the chat. So someone asked which inverters are currently integrated with the transmitter, and Tom thankfully responded to them, let them know that there are many separate SunSpec RSD transmitter devices that can be paired with any inverter, and that we provide one of these. And for a list of the because we had it briefly as a slide, but for the ones that we're compatible with, yeah, we encourage you to reach out to our team to get that current list. You can email info@apsmartglobal.com. You can also visit the apsmartglobal.com website and contact us through that. And there's also additional information on that site. Chris, another question here. Can you use an external emergency stop switch with this?
That is not really unnecessary, because it all happens automatically through the heartbeat signal coming from the transmitter.
But I suppose if they wanted to set up an additional switch, they probably could.
Yeah, let's take that question offline, and we'll talk to our engineering team. That I don't know if there's a possibility to add a secondary EMO, if you will.
Question, can the RSD solution be retrofitted to existing systems?
Yes, absolutely can. So as we talked about in the slide previous, so you can actually purchase both the power supply, transmitter, and then obviously an enclosure for it to go into with a DIN mount rail. That right there, and then also the RSD devices to integrate it on every single panel. So yes, you can use a standard inverter today that does not have any rapid shutdown solution built in by using the total solution, both the transmitter, power supply, and RSD unit.
Awesome. Well, it looks like we're just past our time for the webinar, so we're going to conclude at this time. I just want to say thank you to all of our panelists. Thank you to Olivier and Tom and to Chris for this helpful and informative webinar. We will have more webinars in the future. Just check out apsmartglobal.com to and look at the webinar section just to see what's available in the near future. And just want to thank everyone for attending today. And if you have any questions, you can see the email listed on the screen. Just email info@apsmartglobal.com. And thank you for attending, and we hope that you have a great week. Take care, everyone.